Okay, welcome to this video. What we're going to do in this one is look at question 11 from the SACE 2019 Specialist Maths Exam. And this is the first question in part 2 of the exam, so these are the longer questions. And question 11 is involving a bit of 3D geometry. And so if we look at part A, the first part of this question, we're just asked to calculate a vector product or a cross product of two vectors. Okay, so this is a fairly straightforward question. You're told exactly what cross product you need to calculate. You don't need to do any sort of interpretation with this. You just need to know how to do the calculation. And with cross products, I find the easiest way to remember what to do is just think of it as a determinant. And the first row in the matrix is the vectors in the x, y, and z direction, which is I, j, k. And then the next row is the first vector. And the last row is the second vector. And if you just do that, cross product in this way, you sort of cannot make a mistake. So, or cannot, it makes it hard to make a mistake in terms of sign. It's easy to get the signs the wrong way around with cross products. But now we're going to do the determinant, and so what we need to do is multiply I by the mini cross product of the small square matrix here. And so we're going to get minus 1, minus 0, and then j is going to be multiplied by the mini cross product, but we've got to remember to go in the opposite direction. And so it's going to be minus 1 times 1, which is minus 1, minus 1 times 1, which is also 1. And then k, we're going back to dominant principal diagonal and then off diagonal. And so in this case, it's going to be 0 minus 1. Okay, and if we work that out, we've got minus I minus 2j plus k. Or if you write that in vector form, it's minus 1, minus 2, 1. Okay, so they do these sorts of questions usually with some sort of plan in mind, and so we think perhaps that somewhere in this question we're going to need to use this cross product. But for now, all we've been asked to do is to calculate it, so we've done that. Okay, so now on to part B. And in part B, we're asked to consider two planes, P1 and P2, and we're given the formula for those planes. Okay, P1 is x minus y minus z equals 4. P2 is just x plus z equals 9. Okay, and these are shown in figure 8. That shows plane P1 and the plane P2, and also the line L1, which is the line of intersection between those two planes. Okay, so the first thing we want to show is that the point x, which is equal to x equals 9, y equals 5, z equals 0, lies on both planes. Okay, so the easiest way to show this is just to substitute x into the formula for the planes. So we're going to sub x into P1, and the left-hand side is going to be given by x, which is 9, minus y, which is 5, and then it's, if we go back, it's looking at the formula of this plane here, x minus y minus z equals 4, and so minus z. In this case, it's 0 anyway, so that's going to give us 4, and that's equal to the right-hand side. And now if we do that in P2, let me just change that to a colon. So the left-hand side, remember this is just x plus z, so it's going to be 9 plus 0. That equals 9, and that equals the right-hand side. If we go back here, the formula we're substituting into now is this one here. Okay, so we're able to show that that was so that the point lies on both planes. Okay, it satisfies the formula for both of those planes. Now, part 2 of part B, we want to say, hence or otherwise, show that L1 has the following parametric equation. Okay, and we're given 9 minus t, 5 minus 2t, and z equals t. Okay, now one thing we know is that a point that the vector goes through is 9, 5t. Okay, the other thing that we should point out is that the normal vector to plane 1, so let's write it, normal to P1 is, let's use square brackets. Okay, if we go back to the formula, it's going to be 1 minus 1, 0, because it's the coefficients of the x, y, and z terms here. So looking at these terms here, so it's 1 minus 1 minus 1. And the normal to P2, I just want to do equals for some reason. So it's going to be 1, 0, 1. Okay, so if we want to find the cross product of the normals in those two directions, that's going to be the tangent vector of the intersection line. Okay, so we want to find cross product (1 minus 1 minus 1) crossed with 1, 0, 1. And from part A, that's equal to minus 1 minus 2, 1. Okay, so the line L1 is going to be given by some position vector, let's say R, is equal to some point on the line, and we know the point 9, 5, 0 plus some parametric times the tangent vector. The tangent vector is minus 1, minus 2, 1. Okay, or in other words, let's put square brackets on these. So in other words, if we write this out in Cartesian form, we've got x equals 9 minus t, y equals 5 minus 2t, z is equal to t, okay, which is what we need to show. Okay, so that's part 2 of B. Now moving on to part C. So question 11, part C, part 1, and then question 1. Okay, so part C says we're going to consider a new line, L2, which is given by the equations they're given here. X equals 3 plus 3s, y equals minus s, and z equals 3. And you want to show that L2 intersects L1. Okay, and there's lots of ways you can do this. You can try and find the point where they intersect and show that that point lies on both lines. But another way to go is to say, well, we know that the point A1, which is 9, 5, 0, lies on L1. And let's underscore that because it's a vector. Let's not call it B, let's call this A2. And if we look at the constant terms in this parametric equation for L2, we've got 3, 0, 3, and that lies on L2. Okay, another way of thinking about that, if you just substitute s equals 0, you get that point there. And so the vector between these 2 points, so is A2 minus A1, and that's going to be 3 minus 9, which is minus 6, 0 minus 5 is minus 5, and 3 minus 0. Okay, and then what we're going to do is work out the direction which is perpendicular to both lines. Okay, so we know the tangent to line 1. So tangent to L1 is, we go back to line L1, it's minus 1, minus 2, 1. I'm used to using round brackets on these vectors, but let me change them all to square brackets. Okay, so the tangent to L1 is minus 1, minus 2, 1. The tangent to L2 is 3 minus 1, 0. Okay, and so what we're going to do is find the cross product of those two tangent lines, okay, which will be a vector that's perpendicular to the direction of both of the lines. And so we want to work out the cross product minus 1, minus 2, 1 crossed with 3 minus 1, 0. We've got minus 1, minus 2, 1, 3, minus 1, 0. We've got a 0 in here, which makes things a little bit easier. And so that's going to be, the I component is going to be 0 minus minus 1, which is 1. The J component is going to be 3 minus 0. And the K component is going to be 2 plus, 1 plus 6, which is 7. Okay, and now what we're going to do is work out the projection of the vector between A2 and A1 on this tangent, this line which is perpendicular to both tangents. And so that's a dot product, and so we're going to work out the dot product of minus 6, minus 5, 3, dotted with 1, 3, 7, and that's going to be minus 6 minus 15 plus 21, which is equal to 0. So there's a 0 projection of the joining vector onto the perpendicular vector, and so they must intersect. Okay, so that's one way to do that question. Okay, like I said, there's a few different ways of doing that one. That's one way to do that. Okay, now we want to find the point Y where L1 and L2 intersect. Okay, we know that Z is fixed on L2. Okay, if you look at the parametric form, Z is equal to 3. Okay, so on L2, Z equals 3. So if we look at on L1, we've got Z is equal to T, so T must equal 3 at the point of intersection. Okay, if we go back here, and so we can just substitute T equals 3 into L1. And what we get is 9 minus 3, which is 6. We get 5 minus 2 times 3, so that's minus 1. And we get 3. Okay, so Y has to equal 6 minus 1, 3. Okay, so now, like I said, you could basically have done this previous question, question C, part 1, question 1, by finding this point where if Z equals 3, a point on Y1, and find that the same point exists on the point L1, and you'll find the same point also lives on L2. Okay, so now what we've got is that the point L2 lies on the plane P3, and the plane P3 intersects P1 and P2 along the common line L1. Okay, so P3 is also intersecting with L1. Show that the equation of P3 is given by this form here, x plus 3y plus 7z is equal to 24. Okay, we know the direction that L1 and L2 point in, and so we know the point, which is basically the cross product of L1 and L2, is given by the cross product that we previously worked out. So we can say from C part 1, cross product of minus 1, minus 2, 1, with 3 minus 1, 0 is equal to 1, 3, 7. And that has to be the perpendicular vector to the plane P3. Okay, and the other thing we need to do is find out that P3 also passes through this intersection point Y. Okay, so P3 is going to have the form x plus 3y plus 7z equals some constant. And now we sub the point 6 minus 1, 3, which is that intersection point that we calculated in the previous part, into P3. And what we're going to get is 6 minus 3 plus 21 equals C. Therefore, C is going to be 24. So P3 is given by x plus 3y plus 7z equals 24. Okay, and that's what we needed to show up here. Show that that's the formula for P3. Okay, so we've been able to use some of the work from the previous questions to answer that. So that saved us a bit of time. Now, the line L3, this new line, is parallel to L2. That means it's got a tangent in the same direction. But it's not collinear with L2. It's a different line by the looks of it. It's shown here to be passing through the planes P1 and P2, and not in P3. So the line L3 passes through the origin. Write the equation for L3. Okay, we know its tangent. Whoop. We know the tangent because it's the same as the tangent for L2. Okay, so tangent is going to be 3 minus 1, 0. Okay, so, and because it passes through the origin, it passes through the point 0, 0, 0. And so L3 is given in vector form like this. Let's use R as our parameter. And if we want to write it in Cartesian form, we'd write it as x equals 3r, y equals minus r, z equals 0. Okay, now we want to verify that L3 does not lie on P3, and the easiest way to do that is to sub L3 into P3. So sub L3 into P3, and we'll find that there's no value of r which satisfies the left-hand side equals the right-hand side. So the left-hand side is equal to x, which is 3r, plus 3 times y, y is minus r, plus 7 times z, which is 0 here, so we don't have to worry about that. And you see we've got 3r minus 3r, that equals 0, and that doesn't equal the right-hand side. So L3 does not pass through. Let me spell that better. Does not pass through P3. Okay, not only does it not lie in P3, it doesn't even pass through P3. There's no value of r for which this left-hand side equals the right-hand side. Okay, so that's that part. Now, moving on to part E, we're going to have some interpreting type use of these results. So we're told that particles are fired from a source located at the origin, and they travel along L3, so that new line that was just introduced in the last part. And if the particles travel at a constant speed of square root 10 units per second, show that the particles pass through P1 1 second after they have been fired. Okay, so we substitute L3 into P1, and what we get is 3r minus r minus 0 equals 4. And so 4r equals 4, which means r equals 1. and we're going to also sub, well actually we don't need to sub into P2 for the time being. We're only interested in what happens with P1 at the moment. So let's not worry about that just yet. We're going to have to do that in a minute, but we'll do that in a little bit. So at r equals 1, we've got the point 3 minus 1, 0, and that's the point that we're interested in. We want to know how far that is from the origin. So the distance from origin is square root 3 squared plus 1 squared plus 0 squared, which is root 10. Okay, so it's a distance of root 10, and they're traveling at root 10 units per second. So time is distance divided by speed. In this case, the distance is root 10 units, and the speed is root 10 units per second, and so the time is 1 second. Okay, so that's basically all we need to show. It takes 1 second for the particles to pass from the origin to the point where they pass through the plane P1. Okay, how many more seconds elapse before the particles pass through P2? Okay, so this is when we're going to have to substitute into P2. And so we're going to get here 3 times r, which is x. And there's no y, and in this case z0 because of the formula of the line. And so that has to equal 9. And so therefore r equals 3. Okay. So at r equals 3, we're at the point 3 times 3, which is 9, minus 3, 0. Okay, and we want to know the distance from the origin, or in fact we want to know the distance from the point where it passed through the plane P1. Okay, so the distance is the square root of 9 minus, so the previous distance that we were looking at was 3 minus, the previous point was 3 minus 1, 0, so it's 9 minus 3 squared plus minus 3 minus 1 squared plus 0 squared. Okay, and so that's going to be the square root of 9 minus 3, which is 6 squared, which is 36, and minus 3 plus 1 is minus 2, squared is 4, and so that's going to be the square root of 40, and 4 is 2 squared, and so that's going to be 2 root 10. Okay, so again, so time is 2 root 10 over root 10, sorry about that, over root 10, which is 2 seconds. So it takes 2 seconds for the particles to pass from where they pass through the point, the plane P1 to where they hit the plane P2. Okay, and that's the end of question 11. So that finishes this particular video. I'm going to do question 12 and the other questions in future videos. If you enjoyed this video, don't forget to like the video. If you've got any questions or comments, then post them down below. And I'll be putting up videos on other questions and also other themes, maybe more stuff on how to calculate with three-dimensional geometry, things like distance between skew lines and so forth. So I can put more videos of that type if people are interested in that. And if you want to find out when new videos are posted, then don't forget you can subscribe to the channel and get notifications of those things. All right, thanks very much.